to do 5.4 indefinite integrals, which is the same thing as antiderivatives. If I give you the fancy EducoSoft definition, f of x is the indefinite integral of f of x with respect to x, or simply the antiderivative of f of x. This process is called integration. In respect to this integration, when you have the function plus c, where the derivative equals the antiderivative, since c is not a fixed or definite, therefore, this process again is still called a indefinite integration or integral, right? So what does all of that say? Integration or integral symbol just really means that you are going to take the antiderivative and you're going to have a c on the end because we cannot define, or it is not a definite number that we actually know. Okay, so there are several parts to integration. If we start out with something like here, we have x squared plus 5x. The integral form of this would be this is an integral symbol. It looks kind of like a swirling S. It will be x squared, the integral of x squared plus 5x. The integral part, this is the integral form, the integral part would just be solely the x squared plus 5x. And if we had to know what the variable part would be, it would just be x. That would be the variable that is given. We have several different rules. Today we are only going to do 4. Rule number 1, if you are taking a general variable, x to the n, it is just the same thing as we did with antiderivatives. Again, integration is antiderivatives, where x to the n plus 1 divided by n plus 1 plus c, long as n does not equal to a negative 1. So for example, we have the integral of x to the 5th, right, d sub x. So if we want to find this, we would do x to the 5th plus 1 divided by 5 plus 1, and this would give us x to the 6th over 6. And now we have found our integration. If we are given any constant c, it is pretty much the same type of thing that we were doing once before. Okay, let's say we would take this one, 3x, the integration of 3x to the 6 d sub x. So what they really want you to do is pull the 3 out to the front and do x to the 6 plus 1 over 6 plus 1. Well, that would give us x to the 7th over 7, and then we will multiply that by 3, which would in turn just give us 3 over 7x to the 7th. Now, I did it the way that Educo does it, but you do not necessarily have to do that, all right? If I give you a really quick one in the midst of that, right here, can I make it? If I have the integration of, let's just say, 2x d sub x, right? Well, I do not necessarily separate it out. I usually just say, well, this will be 2 to the x of 1 plus 1 over 1 plus 1, which gives us in turn 2 to the x squared over 2, which would just give us x squared, right? So you may pull the leading coefficient out if you like, but if you do not want to, then that's fine. You can just simply do the antiderivative. All right, rule number 3. If I have the integration of k d sub x, k is for any constant. So if I have the integration of 7 d sub x, guess what? Oh, I'm sorry, plus c plus c. If I have the differentiation of 7 d sub x, right? Well, then this would just be 7x plus c. It's very similar to the last one that we did. If I have the integration of pi over 2, well then my integration of this would be pi over 2x plus c. Always make sure that you add on your plus c. Now, if we get a little bit more intricate, in rule number 4, where we are adding several different terms, then that means reduce as such. Now again, you can bring that leading coefficient out for each term, right? And that'll give me x squared minus 5 to the x plus integration of 8, right? And then you would add plus 1, and then this would be 2 plus 1, and this would be 1 plus 1, and 1 plus 1, 0 plus 1, 0 plus 1. Sorry. Okay, I'm trying to do it as the book does it, right? The next one I'm not going to do it as the book does it. So this will give me 3 times x to the third over 3 minus 5 times x squared over 2 plus 8x over 1, right? And if I go any further, these 3's can cancel out, and this will just give me x cubed. Then these do not cancel out, so this would be a minus 5 over 2x squared. And then just plus 8x, and do not forget your constant c, because there was some particular number, but we just do not know what it was. Okay, and that would be your answer for that one. Now the next one we have is the integration of square root of, or 5 times the square root of x plus 3 over x squared plus 10x, right? So I need some board space, so I gotta erase this, right? So if I rewrite all of this here, this will be 5 to the x 1/2, right? Plus 3x to the negative 2, right? Plus 10, and then that's it, right? So 5x to the 1/2 plus 2 over 2 divided by 1/2 plus 2 over 2, okay? Plus 3x to the negative 2 plus 1 over negative 2 plus 1, right? Plus just plain old 10x plus c, okay? The most work you have to do is just simplifying the rest of these fractions. So this will give me 5x to the 3/2 divided by 3/2 plus 3x to the negative 1 divided by negative 1 plus 10x plus c. Okay, remember, like in the other video, we do not, cannot keep this fraction in our denominator, so we must multiply by its reciprocal. So the 2 comes to the top, so that'll be technically 5 times 2/3, which will give me in turn a what? 10 over 3, and then we'll keep the rest as the same, x to the 3/2. This will no longer be a plus because negative 1 goes into 3, a negative 3x to the negative 1 plus 10x plus c. Now, if I am thinking one more extra thing that I should do is we don't like negatives. We don't like nothing negative in our life, so we don't want anything negative in our problem. A negative exponent always goes to the denominator, and so that should be over ax. And then that will be my final answer. Okay, so this is pretty much the first couple rules of integrations. How long is it? Don't pause it yet.
9 minutes.
9 minutes. Let me do this one extra on there. It's paused. Oh, it stopped. All right, so to finish up, the last rule, number 5, so to make sure you can do at least your trigonometric functions, right? So if you have, let's say, rule number 5 is you have the integral of cosine x d sub x, right? The integration of that, or the antiderivative of that, would just be sine x plus c. So if we wanted to do 4 cosine x d sub x, right? The integration of that would be, we bring the 4 out to the front, and then you have cosine x, right? So what is the antiderivative of cosine x? It would be sine x plus c. So my answer would be 4 sine x plus c, okay? The integrations of the trigonometric functions are relatively easy, long as you know pretty much their basic formats, okay? And we will probably do one or two maybe in class, but overall you should at least definitely know your sine and your cosine without a doubt, okay? And that is it for integration.